This video supports the 4348 Datastore project, and it goes over the installation and the operation and exporting of the project for submission. All right, well, we're starting off with an empty Eclipse workspace, and you'll find on the e-learning folder, there are three zip archives that you've been provided. And we'll go over each of these in turn, except, we need to import them from the archive into your Eclipse workspace. You need to copy them off of your off of the box folder that you'll find them into your whatever directory, and then you can import them from there. So here we go. So just go to the, like I said, mine's empty. Yours might have some existing projects in it, but we're going to go to import and then existing project into Workspace. And then it's very important that you do not use directory, that you use select archive file. If you accidentally import the zip archive using this, I don't know, I think bad things happen. It seems to work, but bad things happen. So anyway, archive file, browse to, and then here are the three archives, and I'll just import one. And then that will bring us to here. We have a source, a test source. We'll go over this in a second, but let's finish. Existing project, archive, student, okay. And then finally, you could also just import from here. Existing, select, browse, testing, finish. Okay, so we have all three in, but there's an error that we need to fix here. So we will go into properties, and right now this project is referencing a project we don't have in the workspace, which we will add in a little bit. But right now, just to fix this error, we're going to remove that and add the student. All right, and then apply, apply and close. And that, cleared up the error. All right, so that's all three. And let's get going on some of the testing. Okay, before we get to the persistent data store, we're going to look at some examples, Echo Server examples that we also looked at in class, but I thought I would cover in the video as well. And so this is a simple, very simple two command or two operation server that does echoes a string back to the client or reverses a string back to the client. And again, that was covered in the section slides, and so I'm not going to go into a lot of the detail in terms of how it's developed, but we'll look a little bit how we run it. So as what we have is two applications. We have the server application, which needs to be running, and then we have the client application, which is really some test cases that exercises the client and a server implementation. And let's see how that works. So I just know that we have our server, Echo Server, right here. And if I open that up, we have that startup, which starts the server running. And here's our server socket, waiting to get a server. I'm going to let you, go through this code if you wish and understand how it works. Remember, this is all in the project, not the project, but the section slides, and talked about it in class. We have a while true loop that loops forever, and here we created a server socket listening at the port number, and then in the while loop we wait for a request, so we call accept, and this accept call will block the thread until a client attempts to make a connection. And once the connection is established, the socket is created right here, and then we have the input and output streams, and then we call parse request with the input stream, which gives us back a handler, and then here's parse request, which reads the first line from the input stream, and then the first line is the command identifier, which determines which handler is created and returned to this code here. And then we set the input and output stream on that handler. Here we have the handler, set the input and output stream, and then call run. And this will essentially, you need to look at the handlers, we'll read the remaining operations, arguments for the operation, parameters from the input stream, do the processing, and then generate a response message from the server back to the client. And then here's the main that gets the whole thing running. All right, we'll run it as in Eclipse. We'll go run as Java application. And here it says, do we want to? Of course we do. And now we see, basically, what we have here. We have waiting for a request, and the thread is blocked waiting for the client. So then we can run the client. Now the client is implemented as, two ways. We have a plain Java application, which connects to the server, sends a request right there, and then receives the reply, and then prints the reply on the console. And so I'm not going to go into this right now. So just going to run that as a application. And here is the server side, waiting for a request received. And then if you want to see the client output, you have to switch to that because the client is terminated, but sending a request, return message, and then, as you can see, the diagnostics, which are being printed here. The port number is being passed in this configuration echo server, which is not sure how deep I want to go into this. Here we have the client, 123, 10,023, and that was the same port number that we used to create the server socket that we then, blocked waiting on. If we go to the client code a second ago and we paste in, did I paste that? No, I did not. 10023, just the same. We get the same effect. Just run as Echo client. Yes. And that works, but if we change it to a different port number and we run the application again, we get an error. Connection refused, and caused by JavaNet connection exception, connection refused. Connection is refusing because there's nothing listening on this machine at port 1033, which hopefully makes sense. There it works again. The reverse client is pretty much the same. Let me move that about. I just want to put this back to what it's supposed to be. All right, anyway, go back here, reverse client, and that will invoke a different client. So here is our client implementation, Echo Server Client Impl, and then we're calling, instead of calling Echo, like we did here, we're calling reverse, the other service provided by the by our Echo server. Run that as a app, and then go to the reverse client. And so this again, this reverses the string. So we send is it time, or is it the time, and then the message we get back is the reverse, which is what we expected. So another way of running these, which is more consistent with how you'll be testing your data store server, is we use a JUnit test case. So this is a JUnit test case class, and we know it because it has annotations from the JUnit library. And so each of these is a test case that we can run individually. So now we can't run it as an application, we run it as a test. And there we ran it. And going back to the terminated process, it worked. And the way it works is, so we ran the test method in test echo. And so we're going to create an instance of our Echo Service Test client implementation, which is, the wrapper for the API, or implementation of the API. And then we create the message, and then so now we have a copy of the original message. And then we have our client, and we call the echo with that message. And because the echo just sends the string back to us, they should be the same. That the result string should be the same as the input stream. And that's what this is doing. This is a mechanism from JUnit. It's an assertion method or assertion test. And what it's going to do is it's going to compare whether the two arguments are equal, the two strings are equal. If they are equal, nothing happens. This method finishes, and and the test succeeds. However, if the messages don't match for some reason, then this method will throw an exception. We can demo that by just putting X here, and then we can rerun the test. Yes. And oh, of course, it sent back XX. Yeah, that worked because it worked as expected. Let me see, what can I do here? Message plus, just keeping it simple. Does this work in Java? Oh no. Gonna wait for it. No. Okay, as expected. Concatenates the two together. And now we'll run it again. Yes. And we get an error. Comparison failure. Is this the time XX? And we expected is the time XX because that's what we were. That's the first argument, the message plus XX, and it kind of highlights that XX is the problem. But was received, is this the time without XX? So that's an example of a comparison or an assertion failure in JUnit as a little demonstration. Put that back. And then the same thing, we could run this method. Go back to here. We could run reverse. And it works. And again, it's the same thing. Well, not exactly the same thing. Here we're sending the string, is this the time? And then I just manually reverse the characters in a constant string, just like that. And if we wanted to, we could, so it worked. If we put an X there, we run it, it will get an error because it doesn't have the X, as you'd expect. This third method, test error, is kind of interesting because, I don't know why, port, address, localhost. Didn't really look at this as carefully as I should have. Well, let's see what happens if we run it. Yes. Okay, well, let's do an error. Okay. I should have paused this a few seconds ago. I'll be right back. Okay. Well, I was fixated on some kind of network error, but it should have worked because everything was looking correct. I didn't realize or see that what I'm sending is a empty string. And so that causes an exception to be thrown by the server, which gets caught by the client. And so what I was trying to demonstrate is that when the server detects a problem with the input, then it throws a special exception, client exception. This is not the client code. So if we were to, so here is the annotation test indicating that this method is a test method, but this is a, I don't know, argument, optional argument for the annotation, and it's saying that this block of code should generate a error, an exception. In fact, it should generate a client exception. So this is a way of testing, your error handling. So when we ran this, it worked. No errors. That's because, again, we were catching, we expected to catch, and when was thrown, this client error. If we comment out the optional argument and then rerun the test, we're getting an error, and it's kind of a weird error, not very not very helpful error. But no one said this was a perfect implementation of a service. Yeah, so we're getting some sort of socket closed error, which I think means that the it went to read the next line for the server side, the handler went to read the next line for the for the string to reverse, but didn't find any, and it through found in fact, the server found the socket was closed, and oh no, I'm saying this is the client. The client finds the socket is closed on the server side and throws this exception. So anyway, what all this is saying is, we have this a mechanism in unit testing which that allows us to specify that a method or a test, I should say, should generate a specific exception, and if that exception is thrown while test calling the method, that is good. That is what's expected, as we saw here. All right, so that goes over how to use the unit testing framework, or JUnit framework, to drive testing of the client and ultimately the server as well. And we will be using that same type of framework when testing the Datastore service implementation. All right. Okay, so now we're going to explore the Datastore student project that I provided in an archive. And what this provides is a partially completed implementation of the Datastore server and client. So what that means is maybe, I don't know, in terms of complexity, 40% of the project is already completed, and it's up to teams to implement the 4 Datastore operations on in the context of these provided classes. Remember that the Datastore protocol includes, write, read, delete, and directory. And these were described in that a set of slides that accompanied the project that you find in the project directory, the Datastore project slides, and also described in maybe more detail, certainly more detail, in the Word document project, Datastore project description. So I'm not going to go over the protocol. I'm just going to go over what needs to be done with the classes provided. So here we have the student project and the things that are of interest, that you need to work on, but certainly not the only thing you need to look at is both the server and the commands and the client implementation. We'll start with the server. So this is the server. It has a main. It starts the server running. And what you should notice, and which will be very handy, is if we go back to the example, the Echo server, and we open up that source, then we'll have the server, Echo server, and wow, it looks pretty similar. In fact, it's almost identical, except for this code in the parse request. So this is the Echo server, and it knows how to respond to 2 different commands with their accompanying handler classes. And then on the Datastore server that you're implementing, you'll see that this dispatch, let's see, do they have the same name? No, this is parse request, and this is called dispatch command, but they serve identical. This is not implemented. So you need to go in and implement the parsing and dispatching the correct server command instance or a class for for each of the 4 Datastore operations that the server and client can exchange. So that is like I say, virtually identical to this, but different in that responds to a different set of operations and require its own set of handlers or server commands. Okay, so where do the server commands come from? Well, here is the base abstract class, which you use as a base class or a parent class of the server command implementations for those four Datastore server commands: read, write, delete, directory. So you'll need a command, a child class, a server command for each one of those four operations. And here is here's an implementation example of echo handler. Echo extends, and then what it does. You need to. This is this is a nice pattern, but the write command, needs to read the data from the input stream and into memory, and then needs to open up a file, using the name of the data set also provided in the write operation, and then to write the binary data read from the input stream into that file, and then if that worked, send back an OK. So something we talked about in class, but that's just to say that going back to the Datastore project, you need to put or create four subclasses of server command, and then each of those server command implementations needs to do the appropriate thing to save, write, or retrieve, delete, and perform a directory operation. I'll say it now. There is, you'll find I provided a number of helper utility, two in fact. So here is a class called FileUtil, and it has a directory. It has a file called data. So you probably will want to read up a little bit about file I/O in Java if you haven't. I think you've seen it already in one of the intro courses, but one thing to notice is that, let's see if we have it here. No, but let's see, well, this is, okay. I'm getting off a little bit here. But getting off topic a little bit here. But in this, in the folder, on the file system and Windows, so if you go to show in Systems Explorer, here this is our Workspace directory, and then here's our project. And you will find, we don't see it now, but once the program's running, you'll find a data directory, or you're going to need to create a data directory into which the files, corresponding to each data set that is persisted will be saved. So I'll just do it. Data. Oops. Don't put a space after it. I'm not sure what that'll do. So data, and then into this folder, it's under the project folder where we're running our application in Eclipse. We have a folder data, and into this folder we should write, or the code should write, each of those files that pertains to a data set, or the files that will be searched when doing the file names for the directory command, and so on. So I'm just making that point that that's what this is about. We have a file called data, and then I'm not. Oh yeah, that would have created it for us anyway. So even if I hadn't created the folder data, here's some code that says if the directory, meaning directory, does not exist, then it makes the directory and then says, hey, I made the directory. And then, so this is write data. So what this is going to do is you'll use this in the write operation, and you'll pass in the name of the data set that was provided in the write operation. I think it's on the second line of the write operation. And then here is the n bytes of data that was read from the read from the input stream. Also part of the write request message sent by the client. And just basically, this is very inefficient. Well, we're essentially writing out one byte after another into the file. There are far more efficient ways of doing this, but this works and it's good enough. We create an output stream. So basically, we'll say here we create a file using the directory as a root and the name we're passing in. That'll create a new file in this data directory. And then we create an output stream that we can write into with that file. And then we go through the data, so we get the data length because it's a byte array, and 0 to data length, and then write each byte of this array into the file. And then once that is done, we close the stream, and the data is written to the file. And then, so I'll let you look at the remaining here. Here's where we read the data from a file in the data directory previously saved and returns the byte array with that data. And then here is the delete, where we're going to pass in the name of the data set we want to delete. And this seems redundant, but at any rate, here's where you get the file, and if it exists. So how does this work again? If file not, here it is. If file not exist, we're going to throw a server exception, no file found, and then we're going to then otherwise the file is existing, and so we'll call delete on that file, which will remove it from the file system. And then here is directory, which returns a list of strings, and so we directory exists. If the directory exists, then it has built in. I haven't looked at this code in a while. This is so this is a file. Okay, file. And then so it'll list the files in the directory. Built in. This is built into Java IO. And then so we get back a list of files, which are objects describing a file. But what we want are the file names. Come on. And so we'll iterate through those files, 0 or more, and we'll add to this result list of strings. So we have an array list, empty array list, and we will add the names of the each file that was returned in list files. And then once that's finished, we return that list to the code that is the handler, the server command handler that is implementing. So these so just to make sure it's clear, these are operations which these are all methods or utility methods which operate on files, and you will need these to implement the server commands for the write, read, delete, and directory command handlers or server command handlers. So pretty sweet. And then there's another utility class, StreamUtil. One second. Okay, this is again, this is another utility class. This is used to manipulate the input and output streams, or to gather information or send information to the input and output streams, on the server side, as needed to implement those 4 server command handlers or operation handlers for write, read, directory, and delete. So each of these in this class, we have a number of methods, which are static public. Same thing was true, by the way, here. These are static public methods, so they can be treated more or less like functions in your code. And the first one is readLine. And so readLine is passed an input stream, and this is used to read one line of information, text, from the input stream, meaning read text from the stream until we see a new line character. So if we look at the write operation, a write request data, we would use readLine, the readLine operation, to read the first line of text from the input stream to get the operation code to figure out which handler to invoke. And then each of the the required two next lines containing the name of the data set and the number of characters in the data. So you could use these functions to read again these three parameters or arguments from the input stream when handling a write request. Or for the read operation, we would read the first line to get the read string, the read operation, and then one more time to get the name of the data set that the read handler needs to open and read the data from and return to the client. So yeah, so these are handy in that way. So this is a handy little function that reads and returns the string, returns all of the characters up to a new line and then returns to the caller as a string. And it's using kind of an interesting little feature of Java called a byte array output stream. So I'll let you look at this, but it's going to look for 1,000 characters. So this is going to limit the search of the data on in the input stream to 1,000 characters. So if it doesn't find a new line after having read 1,000 characters off the input stream, something's wrong. It shouldn't take that long. Maybe, again, from a design perspective, maybe not the best, but it'll do. And then so for up to 1,000 characters, we read the next character off the input stream. We check to see if it's a new line, and this is where the byte array input stream. Well, let's say it's not a new line. It's it's SIMP, SON. As we're reading the second line, we're getting these characters, and so if it's not a new line, we write the code, writes that character to the byte array output stream. So a byte array output stream is just an output stream that writes into a byte array maintained by the output stream. But it's a very handy way of appending characters to a list like data structure, but treating it as an output stream. So we're basically calling this function, or this function is reading from the input stream till again it gets to the new line character, and then it's done. It's found the string it needs. So it will convert the byte array. It'll call the byte array output stream and say, "Give me your contents as a string," which is provided, and return to the client. So again, this is a useful function for reading each of the lines, new line term delimited, operation name or operation parameters from the input stream, by the server from the client. And then here is a read data. So after reading, after the handler, the write handler reads, is read, oh, this is a write operation, so let's use the write handler. The next line, to get the data set name. The next line, which is the number of characters in the data set, the number of characters following this new line here. We need some code or a utility that reads 37 characters from the input stream. So that's what this function here does, read data. It returns a byte array of the data read. It's passed in the input stream to read from and the number of characters to read. And again, the number of characters to read is, passed as the second argument to the, in this example, in the write operation. So from 1 to 37, first it allocates a new byte array of length 37 or whatever length, we're being passed in. And then it's going to iterate 1 through 0 through 36. And it's going to read a character from the input stream, and it's going to append that character to the byte array. And once it's read and appended n characters, it's finished, and it returns the byte array to the caller. Okay, the next one is write data. So write data is really easy. So this is for the read operation where the response message contains the n bytes of data which was previously stored in the file in the data set. So essentially, we want to write OK in the response code for the read operation. OK if we found the data. It would be an error message if we didn't find the data set name, for example. And then the number of characters that were read from the file, and then the data itself. So, how do we write the data? Well, here we're going to. Here, where am I? Right here. Here's the data read from the file, and here is the stream we want to write the data to. And all this, couldn't be simpler. All it does is here's output stream write data. Well, the write method here knows how many bytes to write because it knows the length of the array, and then just call flush. And what flush does is it ensures that the data has been written into the output stream. Because sometimes for optimization purposes, we cache, or the API might cache data before writing it to the output stream. I don't want to get into it. All this is doing is ensuring that the data is completely written to the server output stream, and so being sent on its way to the client. All right, same thing. So here is write line. So this is we could use this in your generating your result message or your response message, back to the client. This is on the server side. So we want to write a line. So basically, this says write line. This is the line of text to write onto this output stream. And it says write line, so we want to make sure that the string we're writing has a new line, is terminated by a new line. So this is just, some simple Java stuff that says, if not ends with a new line, we append a new line, and then we write, just like here, we write the bytes from the string to the output stream, and then we flush the output stream so we know the data sent along. And then here's a little utility function that you call to close the socket. And so just a little helper function, doesn't really do anything magical. And then here is send error. So when we want to send an error, we're essentially sending a line of text, but it's not that much different than it's really not that much different than write line. In fact, as you can see, it's virtually identical. Probably don't even need this. But anyway, send error will basically just sends the text, the error message, terminated if necessary with a new line to the output stream, and then flushes it. Okay, so that covered the two utility functions that I provided in the project to help you read and write data to and from files, and read and write data to and from input and output streams, for the socket connection. And I just thought of something that I keep saying that these are useful functions for the server, and they are, but they're equally useful for the client, for implementing the client. So, that is important as well. All right. Okay, next, I'm going to briefly talk about the classes in the Datastore student project. I kind of went over this a little bit at the beginning of the previous section of the video, but let's do it one more time just to be sure. So we have, you've been provided this project, and it has these classes in it, obviously. And again, this is a partial implementation of the Datastore server and client. So we have both the code for the client and code for the server. The testing is executed using the client, and the server is assumed to be running, for the client to connect to it. So the on a client code, on the client side, is implemented in this class, Datastore client impl. And we had a corresponding class in the in this example echo server. Oh no, that's not it. That's the API. There we go. And so it has these functions, a function for the echo. And this is the echo server, which knows how to echo a string and knows how to reverse a string. And but remember, this is the client side. This would be the side that connects to the server, sends the request message, and then waits and parses the response. And you can look at this, look at it here. One thing that is not, oh no, I'm sorry, some of it's, I was about to say that those utility functions are not being used, but here's an example of them being used, so that was wrong. One thing you won't find, of course, is the file util, because this echo service doesn't write to a file. Anyway, so there's something you can base your implementation on, and this is, of course, implemented in the Datastore client impl class right there, which implements the Datastore API, which is right there. So this is the API that we write against. So back to the implementation. So we have a function for write, read, delete, and directory as defined by the API. And I guess, as you might imagine, your responsibility is to implement each of these client-side methods to, again, open a connection to the server, formulate and send a request message to the server over the socket, and then to wait for the server to send a response message, and then to process the response message and return the data as required. Here we're going to write the data, so we're providing the data set name and a byte array containing the n bytes to be written. And this read, when we call read, the client side will formulate a read operation as defined in our protocol. And then we'll wait for the response message, which will contain the n bytes of data that were saved and returns that byte array of that return of the data retrieved from the server to the caller of this API, to the client using this API, or the program using the API. Delete and directory also need to be implemented on the client side here as well. So again, using the stream and file utility methods or utility functions will greatly help you in implementing this client side functionality. All right, so I think that's about it on the client side. You have to implement these methods. On the server side, I already kind of mentioned we are providing an implementation, a partial implementation of the server. Here's our main, which starts the server running, and you need to implement the dispatch, which had its corresponding method here, where you pass in the input stream, and then it parses the first line from the here's an example of using streamutil, that stream utility, parsing the first line of the input stream and determining which handler to return, and then the handler implements the run method, which now remember, this is on the server side. It reads the input stream, processes the data store operation, and then returns the response according to read, write, directory, or delete. So to implement that, going back to the Datastore server, you need to implement that parsing, and then you need to implement, as I said earlier, you need to implement 4 server commands. Each server command implementation, implements the 4 data store operations. So that's primarily what needs to be done. Implement the client finish the client implementation, finish the data store server, and implement 4 classes for the 4 server command implementations of classes for the 4 operations. And that's all that really needs to be done. Of course, that's the tricky part, right? All right. All right, next I want to demonstrate how your implementations of the client and server sides of the project are tested. So in order to demonstrate testing, I need a completed implementation of the server and client code. And so I've imported my implementation of the project into this workspace. And that's what we have here. It's essentially identical to the server project, except these classes, server, and here are implementations of the commands, and then I'm missing some. Oh, here's the implementation of the client code. So all of these classes are partially implemented in the server project, but are fully implemented, of course, in my version, so I can demo it. Lost a train of thought there. One second. I'm looking at my notes. Oh, okay, right. Now I'm going to make a small change here to the testing project. So remember, the testing project drives the testing of the implementation. Right now, if you remember from the beginning, we had to fix that problem with the project being the import or not being correct. So what am I looking for? Build path. Configure build path. So the testing project is currently attached to the student project, which is correct, which is normal, except we can't run it because there's no implementation in the student project. So I'm going to, remove the student project and then add my implementation to the build path, or the class path really, and that will, and now no errors, but now when we run the testing code, it'll be running against the server um, um, implemented or running from this project. In fact, just to emphasize that, I could close this project and no error. I could also, I guess, close the, no, maybe I want to refer to it. All right, so in order to test the code, we need to start the server. So we go to our Datastore server, and here is our implementation. I'm kind of hesitant to open it up because that will, demonstrate you'll be able to see implementation details. So I'm going to try and keep things closed unless I absolutely have to open them. So here we're going to run our server. It contains a main, right? So we're going to run it as a Java application. And it's up and running. It's running. We can terminate it. And then we want to run some test code. So as I kind of explained earlier, with the echo testing, we have a class which is a JUnit test, and it has several test methods which test the implementation of the of the server as much as possible from the client. So what we have is okay. So we have is illustrated here is we have our Datastore server running now, and it will read and write data to and from its data directory. And so here, one thing that I can illustrate is that data directory is, here's our project. It would be your student project. Here is a folder data, and it won't let me open it in this package explorer, but let's look at it in the Windows Explorer. And in that, it's empty right now, which is good because that's what we kind of I wanted to show you anyway. So right now we have the data directory, the data folder, data directory, where the files will be placed, the data store files, but there's nothing in it right now. So we'll come back to that when we've done something. So that is what's going on here. We have the Datastore server running, and now we're going to, test the client. So we have what we needed was, as I said earlier, we need an implementation of the client API, which was partially given to you and the student as this Datastore client, which is now implemented. And that is what is right here. So that's what this represents. It's an API, a library that clients, applications would use to utilize our Datastore service. Instead of writing applications, though, mains applications to test this client API implementation, we're going to use JUnit testing, as we showed earlier. So let's have a look at that. So that we'll be looking at this client test, which is our JUnit. So that's what we have here, the Datastore client test case. Each one of these methods is a JUnit test, because of the annotation, and each could be run individually or run as a unit. So let's run one individually and go over it a little bit. So here is test write. So here we're getting the address. So let's look at that implementation. Get address. which is going to build an INET address. If you go back and look at the sample code on how the client works, if you go back here and there's some sample code here somewhere establishing this client connection. And so that's essentially what we're doing here. We're getting an address by name. I could fix my demo a little bit. Getting address by name, which is right now local. Oops, no, we don't want to use this one yet. That's the AWS. Maybe I shouldn't have checked. Well, I'm not going to go into it. So let's change it to localhost. So I checked it in. The archive you have, the zip project, is by default talking to the AWS server, and you most certainly don't want to do that initially. So you're going to need to change. So this is important. Pay attention here. You need to comment out the address to the AWS server, and then comment in localhost, which will then connect to the server you have running on this local machine. Save that. And so let's look at test write. Okay, now I should have paused it. I'm going to pause it. Okay, back. Needed to familiarize myself with this. Okay, so let's look at test write. Test write is really not doing anything too magical. In fact, there's very little testing going on, which is kind of what threw me a moment ago. But this is a unit test, so we can run it as a unit test. We get the address, which I just went over, the address we want to of the server. And then we create a new instance of our Datastore client impl, which is what you need to complete. And we're passing in the address and the port number. The port number never changes. It's always 10,023. And then we call a function provided in these unit testing, generate data, which just really generates a string of random numbers of the given size. So create a byte array, create a random, and this basically populates the data with this array with random bytes, or string of random bytes, which then we return. And so back to here. And then we just call write. We have the Datastore implementation, call write, and we give it the name test data, and let's see what happens. So I can select this test write. Where is it? Right there. And now I have to run it as a unit test. And it goes in, it's happy. And we go here, and we'll notice that here is a new, in our working data directory, in our project, this file magically appeared. It wasn't magic, was created by the server. And although we can't really look at it because it's just going to be random data. In fact, I'm kind of regretting that I didn't put some ASCII data in here now, so we could look at it. But that's how that works. And write test 2 does the same thing, except adds a character string to the not a very interesting test. And so it just appends the current millisecond time system time to the file name. Test read, though, actually is a unit test that's actually doing something. Let's run it. And so what that did is it worked. It essentially writes data into a file with that name, test data. So it basically overwrote the existing file. Well, so it generates a stream of data and it stores it in this array data out. So now here's the data that we're going to send, and we send it here, and that just overwrote the existing. So if we delete these two just to illustrate and then rerun that test read, we'll see that see the data file showed up again. And then we read it in. So data out is what we wrote, data in is what we read. And so this array contains the data read out of this file, from the server. And then we test, we do some actual unit testing at this point. We assert whether the size of the data that we wrote is equal to the size of the data that we read in. So if we wrote out data size is, I think 10,000, yeah, or 100,000. What's 100,000? Okay, and so we wrote out 100,000 bytes, and we read the data back in, and it has 100,000 bytes because they assert equals, passes. And then we want to compare whether the contents of the data we wrote is equal to the contents of the data we read back. And a easy way of doing that is to just generate a checksum on the data out and the data in, and because the data is identical or should be identical, their checksums should also be identical. So here we generate a checksum for the data we wrote, and here we're creating a checksum for the data we read in, and here we're asserting that these two checksum values are equal, and if they are, that means, clearly, right, we wrote the data out as the data we read in. Okay. And then there's some others. I'll let you look them over. I don't want to go over all of them, but there's a test case for every one of the 4 operations. And that's what I'll have to say. Oh, one more thing, I guess. Yeah. 2 more things. Let's see an error. So we'll like test read. Well, let's say we say the data in length, +1, so that the 2 that the data we wrote it has fewer characters than the data we're reading in, just to see an error. So yeah, and then we get an error, red error, and then we can select here again, and we can say, oh, we expected to see 1,000, 100,000, but we found was 100,001. So if you read in or return, if your server returns fewer or less data in terms of size, then this assertion fails and you get an error. And what else was I thinking? Oh, another thing about JUnit testing is you can go in and how do I get out of this? Let me go back here. Oh, if we select the class itself and run as JUnit test, it runs all of the tests. So you don't have to run each test individually, as I was demonstrating with a moment ago. If you just want to run all the tests, you just don't select the individual tests in the class. Just run the class itself, and JUnit does the thing it's supposed to. One more thing, right, is so at this point we're running against the server on localhost, right? And that was referred to in the documentation as phase 1 testing. So phase 2 testing, I think that's what it was called, is running the server against, I'm sorry, running the client against the server running on AWS. So not sure, as I talked about in class, not very difficult to be honest, set up an EC2 server, made it public. I set up a server that had, I used an image, a machine image, provided by AWS that, included a Java runtime. And then I copied the executable jar file onto that server, and I ran the Java the Datastore server in the background. So, all long story short, or short story long, we now can run against. If you can change the address from localhost to this EC2 AWS DNS name, and run the test cases again. I could just, I'll do it from here. And the major difference is it runs slower, right? If you notice, if you go back and compare running on the running against this localhost server versus running against the remote AWS server, it runs, a bit slower. Not really, really slower, but it runs so much slower because, of course, it's going over, into the internet. It's no longer localhost. It's going over the internet to AWS through their infrastructure, to the machine that's running. So it's a little slower. But anyway, it illustrates that, the API, that the protocol on the client side is set up correctly. Okay, well, that's all I can think of at the moment. Let's carry on in the next section. Looking at my notes, I forgot something. So this is something you might run into, and which in past semesters students have had problems understanding. So I just wanted to bring it up now. So say, for example, you're doing your development, and you have your, you have your, you're developing your server, and it's partially completed, and you go in and you run it. Okay, I screwed that up somehow. Let's have a look at that again. Run as. Yeah, I did something wrong here. All right, and so the server's running, right? And you do your testing, and you find a problem, right? And so you go in and you make changes to your handlers, your server command handlers, or the client side. You fix the bug, and then you say, "Oh, let's run it again," and run as. In fact, you could just go up here and say it keeps a cache of the things you previously ran. So let's run Datastore server again, and oh wow, a new error. What the heck? So what it's saying is address already in use. Okay, so the problem is this: you've left the server running on localhost. And so with it running and bound to the port, when you try and start a second instance of the server, it's going to try and bind to the same port. But, as we said, on a particular machine, only one process can be bound to a port. And so you're trying to create a second process and bind to a port already occupied by a running process. And you're going to get that error. So you always have to make sure you kill the previous instance of the server before attempting to run the server again. Just want to make sure that was, I wanted to point that out because, as I said, that is sometimes a problem. Okay, at this point in the video, the assumption is that teams have completed both the client and the server um, implementations in their projects, and they've tested against the server running on localhost, their own server, and they've also tested against the server running on AWS, and so they're ready to turn in more or less. So you need to build an executable jar file. Now, in the project description, it mentions, or I may just go in and change it, needing two jar files, one for the server and one for the client. But really, you only need one. And I believe the description already mentions this. You only need one jar file that can serve as both the client API and the server executable. Okay, so in Eclipse, we want to build an executable jar file. But I had some problems with it. I spent a lot of time trying to figure this out. If I go, I don't know if I should just show you the error and then show you how it works, or I think I'm going to do that. I'll do it just take it from the top, so to speak. So what you need is you need a launch configuration to build an executable jar file. So if you select your student, notice this is your student file, and you go properties, okay, you have this properties tab, and you select run debug settings, and you might have nothing here. And I won't go into my confusion here, but finally what I've realized I needed to do is create one, and so new, and then what type? Well, you want to build, what we're building is a configuration that we can launch the server from. So we want to be able to launch the server, which has a main, from the desktop using an executable jar file, and we'll demonstrate that. So a Java application, and then we need the project that we're going to assert. What we're doing is we're looking for or identifying the class with the main that will be used to launch the executable or the application when we're launching or running an executable jar. So first of all, you have to make sure that you're using none of the others, your student project. And then when you hit search here, this is a little trouble with this, but anyway, when you hit search here, you're going to see your Datastore server. Okay, that is with the main. So click on that, of course, and now it's set up. We don't have the jar file yet, but we do have a launch configuration that we can use. Oh, I want to give it a name. So something like DS student server, or whatever we want to call it. I don't care. That doesn't matter. And then apply, and okay. And now we have a launch configuration. So apply and close. Now we want to export the jar file. So we go and right click or go export and runnable. And so under Java, you have to, might be here by default. So under the Java, runnable jar file. And now you pick the launch configuration and, DS student server. And that's it. You hit finished. Now it's going to complain about repacking reference libraries and do you have permissions, and I don't care. Yes. And then a warning, but I don't think there's anything interesting. Oh, well, there's some warnings. Yeah, so I don't get rid of all the warnings. Very sloppy of me. Okay, so now, I kind of skipped something there pretty quickly because I already had it set up. Let's go back to export. Do that again. Runnable jar file. So we pick the executable, but we also then have to pick where the jar file goes. So, and I skipped that before. So I'm just putting it under my C temp directory, just, kind of a throwaway trash directory. And I have a directory, Datastore server. Let me get rid of it and so I'm going to put it there. Any directory will do, desktop, it doesn't matter. And so then I'm going to use that. There's my name. I guess I'm going to change it to student. save, and then finish, and then OK, and then OK, and then in that directory we have the student ds.jar file. Now I can't demonstrate how to run the server from this jar file or from this project because, as I've said before, my version of the student project is incomplete. It's the original version before changing. So I'm going to start this over again so that I can demonstrate it running. So I'm going to do another jar file, but I'm going to do it from my implementation. So I want to open that project up first, and then I'm going to go in and make sure I have a run configuration, which I don't think I do. So well, I guess I do. See, here's what's confusing. I didn't set this up. It just showed up by itself. This is correct, right? Yeah. I don't know why. Anyway, if you don't see a launch configuration, you need to create one. Make sure it's associated with your project. Now this is my implementation project, persistent data store, and there's the project here. Go back and look at the previous bits of this video a few minutes ago, and you'll see you want to build it from the student project, not make sure you're building out a student project. That's all. All right, well, I have one. All right, so we're good to go there. And so then we're done with this. And then we go here again. I'm going to select my project and export and Java, runnable jar file. And now I want to pick the launch configuration for persistent data store server. That's just the one. And then see, this is the name of the project, and then this is the name of the file, the file with the main. And now I'll change it to a different name just to make sure it's working correctly, and I'll make this master. And all that. Okay. Okay. And let's do one more thing before we look at running the executable jar. We're going to another of the required artifacts that you need to submit for grading is the project directory itself. So you could zip this up from the file system, that would work, or you could go to export and now go up to archive file and hit next and select the project that your implementation, and then let's put it into not there, but let's put it into the temp directory like I did the other ones. Oh, come on, give me a break. C. Oh, this be C, then C, then temp, then DS. What do I call it? Data store. Yeah. And then give it a name. Team, data store. This is a naming convention in the document. Data store project. The important thing is you put your team number on it. Team in the file name, on the file name. I want the team numbers on the file name so I don't have to try and figure out which team belongs to which archive. And then I don't know if I'm going to put zip on it. I don't think it's necessary. And then do save. And so now we have a destination for our zip archive, and everything else is a default. And we hit finish. And now in that directory, we also have our zip archive of our project with the source code. That is what I am after. I want to be able to look at your source code and make sure there's no cheating going on. Not that you cheat. Okay, so you have the two archives you need, and then I'm going to kill this section and move on to another section of the video where we do the exercise with the jar file. Okay, now I'm going to demonstrate exercising the jar file or using the jar file. Um, so, so we need to run the jar file as an executable, which we set up when we did the export in a previous section. So now, if I go to Open PowerShell here, so this is the jar file we just made, and it's in my temp directory, just to point it out. And here we are. Oops. All right. So this is how you run an executable jar. And master. And then the service is running. And then on the testing program, if you've noticed, the class path is set up, to link to the implementation. It would normally be linked to your student implementation, but at any rate, we want to remove either. Nothing here. And then in library, I think I forgot to do something here. I'm going to copy this into this directory, into the testing directory, so it's easy to find when I do the when I set it to the library path. So back here. All right, so get rid of the project and go to library and then add external jar. And there you'll see nice. Oh, that's not what I thought. It'll do. Normally it would find this directory, but I'm not going to worry about it. So, and so now this jar file with your implementation, class files and all, is in the class path of this executable. Again, the project, no projects. In the project tab, apply and close. And then, let's see here. Run as JUnit test. Oh, did it again. Running against the AWS server, no good. Although, that'll need to be working too. Well, so I guess to say, rather than throw it away and start over again, this is this is a test as well. So now, to point out, the project on this testing project is now using your jar file, and this is another test I will be doing. I was going to demonstrate this after the local test, but so I'm going to have the client point towards my AWS implementation, but again the client is using your jar file that you provided, and it worked, right? All the tests worked, running against with your client implementation against my I hate to say I keep saying but my server implementation. So that's a winner. Now let's test against the local. And so we go back, well, we don't have to go anywhere, right here. So we switch the address. I should make this a command line or something. This is going to get, in the past it always is tedious. Anyway, so now we're running the test again. And drag that out so we can see it. And now it's running against your client implementation is running against your server implementation. And everything is good. So I think that's it. I think that's all it amounts to. You'll be turning in the zip archive as described in class and described in a lot of detail in the project description. And of course, you'll be dropping it into the box folder. That's all I can think of. So that's it for the video. Hope you found it useful. Let me know if you have any questions or if you find any really glaring problems. I'd appreciate a heads up as well. All right, thanks.